So, hello everyone, and welcome to our video recording for the Azure Spring Clean event 2021. First of all, we want to thank Joe Karel and Thomas Thornton for organizing this great community initiative to promote well-managed Azure tenants, and of course for allowing us to deliver a topic where Karel and myself want to help you to get started with high availability and resiliency on Azure. But before we start, let us shortly introduce ourselves. My name is Matthyssen. I live in Belgium where I work as an Azure technical advisor. I'm also a Microsoft certified trainer and Azure MVP. And community-wise, I'm a founding board member of a Belgium user group called MC2MC, where we focus on Azure and Microsoft 365. I also have my own blog, https://wmatthyssen.com. And like most IT professionals these days, I'm also on Twitter and LinkedIn. So if you ever want to reach out, just say hi or ask a question, you can always contact me through my Twitter handle @Matthyssen. And I think I can let Karel introduce himself now.
Yeah, so from my side, hi and thanks for joining. My name is Karel de Winter. I'm a solution architect at Dexmag. I'm also running a Tech9 user group in Belgium that is focusing on IT pros and also a lot of Azure things related. I'm also a Microsoft certified trainer and recently been nominated as an Azure MVP. You can find me at Twitter or LinkedIn or just visit my blog at kareldewinter.com. And from that, we are going to start with explaining what availability is. So availability is also defined as the proportion of available services in Azure compared to the total number of services. So availability is a quality and a measurement for a system or a service that you are using. So now that you know that what availability means, in the following sections we will concentrate on the first approach that is needed. And on different things. So we are going to tackle the planned maintenance or unplanned maintenance. Those are two different topics, but very important topics that you need to know which topic or thing that is concerning the availability of your service. Very important, if there is an error or a damage, you have to know what impact it has to be on your application or on your infrastructure, and how much time you need to repair or to eliminate those errors and damage. Mostly the availability is given in a percentage, and for that, Wim, you can show us more details on those percentages.
Yeah, that's completely true, Karel. So when you look at availability, it's quite important that you also know what an SLA is. Well, an SLA is a contract between you and your cloud service provider. And in case of Azure, this is Microsoft, which guarantees you a certain degree of availability for the services you use. So it kind of describes Microsoft commitments for each Azure product's uptime and connectivity. SLAs together with availability is described in terms of nines, such as you can see on the slide. For example, 4 nines means 99.99% uptime, which translates to 1 minute or less of potential downtime per week. Just keep in mind that your applications or workloads mostly depend on multiple Azure services, for instance, virtual machines and storage. And all those services may have different SLAs, so keep that one in mind. If you, for example, look at the SLA for Azure VMs, you can see that there is an SLA for any single instance virtual machine, which is different depending on the disk type that VM uses. Those SLAs connectivity numbers range from 95% until 99.9%. Just know that this is a financial backup guarantee uptime SLA, where you only get your money back in the case you submit a claim. Of course, you can also foresee high availability for your VMs, which guarantees an SLA of 99.95% in case of an availability set, and 99.99% in case of an availability zone. So Karel, back to you.
Yeah, so we have to build 5 nines then.
Yeah, that's true.
Yeah, so next we are going to explain what resiliency means. And if we see on the next slide, we have 3 different things that we can do to assure those 5 nines and to build those resilient applications. So first of all, we have the high availability concepts that we know and can use in Azure. But next to that, we also have backup that we can use, of course, and disaster recovery. Those are 2 different things, but we need to explain those in detail. Those are 2 friends of ours. Those 2 guys are still laughing after a very an hurricane has hit their country. Their complete data center has been flooded, but yeah, for now they are just swimming in the problems here and still smiling because they have they have those resiliency topics put in place. They have backup, they have disaster recovery done right, and they have configured the high availability. So that's very important to know that you have to build reliable systems on Azure, but yeah, that's a shared responsibility. So you are responsible for building your application in a resilient way, and Microsoft is responsible for the reliability of the total cloud platform, including those global network things, including those data centers that they have all over the world. But keep in mind, you as a customer, you are responsible for the reliability of your own application, and you have to use for that those architectural best practices based on the requirements of each workload. So not all workloads need to be high available across different regions. You have to figure that out at first. So up to you, Wim.
Yeah. So like Karel already said, availability is one element of Azure resiliency. In case of your Windows and Linux VMs, you can foresee high availability by use of an availability set. You simply can see an availability set as a logical grouping for isolating your VM resources from each other when they are deployed. This ensures you that during planned or even unplanned maintenance, at least one virtual machine is available. In the back, these VMs will be spread across different fault and update domains. A fault domain is essentially a rack of servers, and you can see an update domain as hosts that update together. So to foresee resiliency for your IaaS VMs, you should at least place all your production workloads in a separate availability set. You can have an availability set for your domain controllers on the IaaS, one for your web servers, SQL always on, or every other workload you can simply think of. And for complete redundancy until the storage level, you should always use managed disks for the VMs you place in such an availability set. So Azure makes sure that the VMs you place within such an availability set run across multiple physical servers and network switches, all in their own compute racks with their own storage and power units. If a hardware or a software failure happens, only a subset of your VMs are impacted and your overall solution stays operational. So you can see availability sets are essential for building reliable cloud solutions, which will ensure that at least one of the VMs will be available if something happens, like hardware malfunction, and this in a single data center. Next to availability set, you can also place your VMs in an availability zone, which is the next level to foresee Azure Virtual Machines high availability, because all VMs in an availability zone will be placed in different physical locations within an Azure region. And this physical separation will protect those workloads from any data center failures. Just an important thing to keep in mind is that availability zones don't support all VM SKUs.
Yeah, and if we look next to VMs to our applications, then we can see that, for example, for an app service, we can have different SKUs. So you have a standard or a premium tier, and with that, you implement resiliency within your application. So if you have an app service, you are not responsible for the VMs that are backing up those services, but you can you can have different tiers that are making those apps more available across different regions, or are scaling up or scaling down when needed. Same for storage. So for your application data, use geo-redundant storage, so it's backed up by the Azure service itself. And for the VMs, the disks of the VMs, always use managed disks, because then it's managed by Azure and it sits on Azure storage. That's also redundant across data centers or redundant across regions. And for your SQL databases, for example, on this little diagram, we see that we have a SQL that is replicating to a different region. So you can have geo-replication for your Azure SQL databases. For that, if one region fails or goes down, your application will fail over to the other one and will have the active data in the SQL database. And for that, your application will be accessible in another region. If you want, you can implement Azure Traffic Manager to just route your traffic not to region 1, but to region 2 in case of region 1 is going down or is failing.
So another element to foresee resiliency in Azure is via backup or disaster recovery and disaster recovery. In the case of Azure, you have Azure Backup for backup and Azure Site Recovery for disaster recovery. The Azure Backup service keeps your data safe and recoverable by backing it up to Azure. For example, a user's delete a file and you can restore that file, or a virtual machine is not responsive anymore and you restore that VM from a backup. Now, site recovery, like I already said, Microsoft Azure Disaster Recovery Service is something completely different because it replicates workloads running on a physical or virtual machine from a primary site to a secondary location. When an outage occurs at your primary site, you fail over to the secondary location and access apps from there then. When the primary location is running again, you can fail back again. So you use Azure Site Recovery or Disaster Recovery when a complete data center fails. You do not use it to restore a single virtual machine or even more virtual machines, and especially not to recover from data loss.
Yeah, and next to that resiliency topic, we also have the auto scaling possibility. So different services in Azure have already built-in auto scaling availability. So for example, if you have an app service, not the Azure functions, but for the app service, you have the built-in option. Also for the VMs, you can use scale sets to expand your workload and VMs across different VMs. But for Azure Functions, for example, it's different because that's already done for you. So it does not support or it does not need auto scaling, because the built-in auto scaling mechanism is handled automatically for you. So for that, the built-in option on Azure VMs is a special case. Yeah, because they, like I said, they only work with VM scale sets. So important to know, if you want to scale your VMs, you have to use the scale sets and just have a look at the different services, because most of the services have already built-in automatically scaling possibilities.
So another important thing to be aware of is that there are different types of data replication you can use within Azure. First of all, the most simple one is locally redundant storage, or LRS, which copies your data synchronously 3 times within a single physical location in your primary region. Then you have zone redundant storage, ZRS, which copies your data synchronously across 3 Azure availability zones in your primary region. You can also choose for geo-redundant storage, GRS, which first copies your data synchronously 3 times within a single physical location in the primary region using LRS, and then copies your data asynchronously to a single physical location in the secondary region. And finally, you have geo-redundant storage, JetCRS, which copies your data synchronously across 3 Azure availability zones in the primary region using ZRS. And then it copies your data synchronously to a single physical location in the secondary region. Keep in mind that with GRS and JetCRS, you have the read access option, which also allows you to read the data in the secondary region. We hope you see that you have a lot of options you can choose between, all with different prices and with different availability. So definitely keep this in mind when you're designing any new solution or when you're doing any new deployment, greenfield or brownfield to your Azure environment.
Yeah, and for the next topic, so it's very important if you have your services resilient across regions. How are you going to handle the requests that are coming into your application if they are spread across different regions? For that, we can use services like, for example, the Azure Load Balancer. So the first thing that we need to discuss here is the Azure Load Balancer. That's for evenly distributing the load to your across a group of backend resources or even servers. If you see in this diagram here, we have a web tier that exists of different VMs, but we have also a business tier that has different VMs. Both are exposing different ports, so port 80 or port 443, to access those resources. So with the load balancer, you can have a high availability on network performance to your applications, and the load balancer will distribute the inbound traffic to the backend resources using what they call load balancing rules and health probes that are responsible for saying, okay, that VM is still up and running. I can request that that incoming request, and I can handle that request. Very important to know is that, like I said here on the slide, the load balancer is operating at layer 4 of the OZ model. So that's very important. And with the load balancer, you have different SKUs. So you have the basic and standard SKU, and you have the internal and the public load balancer. So both are load balancers, but they have different intentions. So the public load balancer will be exposed to the internet. The internal load balancer will not be exposed to the internet. And both can be used for inbound as for outbound scenarios as well. So you can have a load balancer within and across zones, but the load balancer is not a global service. We will talk about a global service in a moment, but it will stay in your region, and it supports IPv6. That's very important to know also. Up to the next one, Wim.
Thanks, Karel. So after that look into the Azure Load Balancer, let us now look into Azure Application Gateway and how it fits in this story. So an Azure Application Gateway is a web traffic load balancer that enables you to manage traffic to your web applications and operates differently than the standard load balancer, which operates at, like Karel says, at layer 4. The application gateway operates at layer 7 of the OZ model. Like you can see on the slide, it can make routing decisions based on additional attributes of an HTTP request, which can, for example, be an URI path or host headers. And for example, this allows you to route traffic based on the incoming URL. Next to that, it will also allow you to redirect traffic, which can help you, for example, to enable automatic HTTP to HTTPS redirection. And if enabled, it protects your web applications from common exploits and vulnerabilities through an Azure Web Application Firewall, or shortly said WAF. So Karel, up to the next one.
Yeah, so the next one is Azure Frontend. Very important service, very good to know. And Frontend enables you to define, manage, and monitor the global routing of your web traffic. So it's a global service. That means that it has a scalable entry point that uses the Microsoft Global Edge Network. So across the globe, you can use Frontend as one entry point, and with that create very fast and secure scalable web application, and that web application can have contents that are in a global setup through Azure. So very important. It also operates at layer 7 of the OZ model, and it has backends in any region, and it can scale automatically for you. And it also enables you to route your traffic, but also to optimize the web traffic for best performance, and have instant global failover if needed. So if one region fails, it can automatically fail over to another region, because it's a global, and it's also a multi-region service. So based on the routing method you are selecting, you can have you can ensure that the front door is routing your client requests to the fastest and also most available application backend across the globe. And also an application backend can be any internet facing service hosted inside, but also very important outside of Azure. So you can have also the web application firewall, like Wim said. You can have free SSL certificates. It can do path-based routing based on a specific URL, and it can use also custom domains. So it's a very important service to know.
So, and then we also have the Azure Traffic Manager. Azure Traffic Manager is a DNS-based traffic load balancer that enables you to distribute traffic optimally to service across global Azure regions. Therefore, it uses DNS to direct the client's request to the appropriate service endpoint, and this based on a traffic routing method. This endpoint can be an internet-facing service hosted inside or outside of Azure. And for example, it can help you in the case you have planned maintenance. And to do this without downtime for your applications, you can use Azure Traffic Manager, but because it can redirect the traffic to an alternative endpoint while the maintenance in progress is. And if the maintenance is done, you can switch back to the original one.
Yeah, and for the next and last one, we have the Azure CDN. So the CDN is the content delivery network. Very important if you have a very big web application that has content that needs to be cached in different countries around the world. Then you can use the POPs, the point of presence, from the Azure network, and you can host the static content in one of those POPs. So if somebody accesses your application from Europe or from the US, they have a very fast experience because the content is cached locally across those POPs, and can be very fast. So you can bring also your own custom SSL certificates, if you will, and it's a global service, and it's a traffic that you can measure with very broad metrics. So you have a very fast experience of your web application, and also it will reduce the traffic spikes that you can have if your application is only hosted in one region. So you will introduce latency. If you are using the CDN, you will avoid that, and your traffic is coming from different locations, accessing the CDN first, so the content that you need is being provided, and in the backend he is being routed through the nearest to the nearest Azure service that is hosting the web application. So those are the different services and availability options you should know. For that, Wim, I think we can close off.
Yep, that's true, Carl. So yeah, like I already said, this concludes our talk about Azure availability and resiliency. So I think Carl and myself, thank you for your attention. And if you have any questions, you can always contact us through our Twitter handles. They're on the last slide, and we love to answer any of them. So this, yeah, leaves us to just saying goodbye until next time, I think.
Yeah, thanks for watching and happy cleaning. Bye-bye all.
Bye-bye.
Bye.